All right, boys and girls, here's what we are gonna do. Let's see, this is the last homework that I'm gonna do for you guys with a video, and I'll be back in person for you. So let's do this one right here. This is the page 191 and 192 in the Brown Book, number 3, part A through E. And then we'll go to page 198 and then 199, do 19 through 23, shall we? So let me zoom in a little bit. Whoa. There we go. So this one's pretty easy, I think. This is an equilateral triangle. It's isosceles too. All the way, yeah. Anyway, so this is 60, right? Because, it has to be. This is 15 and that's 15, right? No problems there. I hope that one was super easy for you. Now, I remember doing this one a little bit ago, and at first I got a little confused. I had to refresh my memory, I guess, is the best way to say it. I had to refresh my memory about kites. And yeah, so here's the thing. These two intersect. Those two diagonals intersect to make a 90-degree angle. That's a key piece of information for you, okay? This right here, these two angles, they get bisected by the diagonal, and this diagonal is bisected by the other. That's why those two are the same. So these two angles right here, PSR and RQP, they're equal to each other. And A, which is from QPT, and SPT are going to be equal to each other because the whole thing, SPQ, gets bisected. So anyway, this has to make 180. That means the leftover is 50, so each of these is going to be 25. Okay? This is a 90-degree angle, so that's 25. Then this is going to be 65. Yep. Okay. This is 30 for sure, because it makes a 180, right? That makes this 60, which makes this 60. Boom, done! Man, look at that. That's fancy. Okay, moving onward and upward. Excuse me, it's not a COVID cough, I promise. Next one's pretty easy. Unfortunately, they actually didn't write this one very well for us because it doesn't tell us that this is the diameter. It doesn't tell us that's tangent. It's leaving it for us to assume, which is really a bad thing to do, to assume, but we're going to have to in this one. So B is 90. B is 90. A is going to be 40, because if this is tangent and that's the radius, then it's going to be perpendicular to, these two lines will be perpendicular. So if that's 50, there's 40 left over, which makes C 50 as well, because 50, 40 make 90 plus 90, right? Okay, onward and upward, we have some parallel lines. We got some transversals. This is 30, which makes this one 50. Those are co-interior, so this is going to be 70. Man, so far that's not so bad. Let's see how part E is here. Oh man, I didn't erase my work from last time. Hold on. Here, let's go over this together, shall we? Let's do this one. All right, sorry about that, boys and girls. All right, so first off, A is 90 for sure because it lies on the center. That makes B 40 because this is 50 and they have to make 180, right? This is going to be an equilateral triangle because those two sides are the same. This is 60. This is 60. Which makes D 60 because they have to add up to 180. That makes E 120. All right. This F is 30 because this is a right triangle because it's an inscribed triangle that lies on a diameter. So if this is C was 60, that's 90. That makes G 30 as well. Man, that wasn't so bad, now was it? Let's go to 198, 199. Okay, 198, 199. Now. These things right here, sometimes I have a little trouble with symmetry. So let's talk about rotational symmetry. When I rotate here, it doesn't line up with itself because this part with the circle doesn't go all the way through. That would be up at the top. So this has a order of 4 and lines 1, 2. If I drew a line there, it would 4. So 1, 2, 3, 4. It has 4. I think it's 4 and 4. For number 19. Let's look at number 20. Number 20 says write down the order of rotational symmetry for this diagram. So it's going to be 3, right? Because we're going to say these are different. So when you rotate it that far, it doesn't line up, but you rotate from here to here, it does, okay? Lines of symmetry, none. No lines. Now remember, the order is always going to be at least 1, but lines can be different. Okay. Next up, calculate the interior angle of a regular heptagon. A regular heptagon. So that's going to be 180. It's going to be 180. Heptagons have, thinking of the answer, 7 sides, so that's 180 times 5. Divided by 7. There we go. It's like, I don't know, let me see. I should be able to do that in my head, but I don't want to. 900 divided by 7 is 128.6 degrees. All right. C. Mon limon. Now, let's see. Part B. A parallel, it's 130. And we have to figure out all of the stuff in here. So this is going to be 50. That's isosceles. That's 50. So that makes 100, 100. That makes that 80. That makes this 80 because they're alternate interior. And that makes that 50. There we go. Man, I've seen this problem before on a quiz. People, just a disaster. People really mess that one up. They get all the 80s and 50s mixed up. So look, here's why this one's 50 right here. This is 50 because look at this triangle. These two sides are the same. That makes this isosceles. If this is 50, because it makes a straight angle, right? Then this one has to be 50, which makes that 80. This is alternate interior. These two are alternate interior. So there we go. All right. Let me erase all this stuff. This isn't the school's textbook. It's actually mine, but I want to erase it anyway. It's a bad habit. All right. What is the special name of the triangle ABC? Oh, that's in the previous one. Oh, isosceles. Work out the vein. Oh, we already did that. Okay, now in the next one. JK and L lie on a circle. So they're on the edge of the circle. KOL is a straight line, and it goes through the center. O. JK is 65 degrees. Figure out why. Well, if this is a right triangle because it lies on the diameter and it's inscribed. So 35. No, 25. 25 degrees. Man, fancy that. 25 degrees. Okay, are there more? Let's see, we have to do through 23. So we got the rest of this page. I've seen this one before on quizzes too. Calculate BCE. BCE. So this entire angle. Oh, wow. All right. So to do that, I think we have to figure out this angle right here and this angle right here. This is 25 because these two lines are parallel and that's transversal, so alternate interior. These two are co-interior, so that's 50. So I think it's going to be 75 degrees. 75. Okay, last one. 23, 23, 23, however you want to say it. EG is the diameter. Okay, good. It tells us that because there's no way to tell otherwise. Yeah, E, C, the circle. So those points are all on the edge of the circle. AEB's tangent, so that's 90. Angles, that one right there, 68 degrees. Calculate CEG. ECG. Okay, we're going to calculate all those. CEG. CEG. So this one right here, if that's 68, this has to be 22 because that would make 90. And this is parallel to the radius, which is half of the diameter, so that's good. ECG. ECG. So that's 90 as well because it's a triangle that lies on the chord, or on the diameter, sorry. CGE, if that's 22, and that's 90, so then this is going to have to be 68. Oh, yeah, 68. Oh, even, oh. Yeah, 68, okay. Yeah, that makes 90, okay. And ECD. ECD. Oh, that one's tricky. That one's tricky. Here's why it's tricking me. It's tricking me because, let's see, this line and this line are parallel, right? It's 68. This is 68. And the reason I know that is, see this line right here and this line right here are parallel. This is a transversal. These are alternate interior. Hope that was helpful, and I'll see you guys soon.